Okay. My name is Doug Purdy. I am a program manager on the wonderful, the incredible, the amazing Indigo team. And I am here to talk to you today about serialization. We're going to talk about XSD, we're going to talk about the CLR, we're going to talk about web services, we're going to talk about serialization, and we're going to have a lot of fun. And this is the last talk of the day. That means I can talk as long as I want to. So we'll try to get done around 6:30, and then we'll go to Ask the Experts. So anyway, so let's begin. And how we'll begin is I will show you a slide you cannot read. And if you squint really close, or if you run up, what you see here is this is the wonderful WinFX diagram that you've seen in many keynotes. And if you look really, really closely, you'll see some red circles, and take my word for it, they all say serialization. This is just showing you that, yes, serialization is part of WinFX. Yes, we're going to talk about serialization, and once you take a look at the object model, then you'll see where we're located. So just remember these red circles. Now let's look at our agenda. I do have some slides. I'm going to try to spend as much time as I can in code and showing XSD and showing WSDL and showing the new programming models that we're about to show you. But before I get there, let's just at least look at the agenda. First, we'll have an overview. I want to make sure everyone in the room is in the room for the right reason. So we'll talk a little bit about what serialization is, and at least what we currently have in terms of the things that we have that can address serialization in V1. I'm going to talk about WDB. I'm going to talk about our serialization story in WDB, and then once we've set that, we're going to talk about what we're doing in Indigo. We're then going to talk about what you need to know today in order to get ready to move to Indigo in the future. We'll talk about what's in those wonderful bits that you have. I assume everyone got those on Monday, I believe. We'll talk about what we have in there for you in regards to serialization. And last but not least, we'll do a little wrap-up, and then we'll have some discussion. I want to have enough time for questions, but I will be at Ask the Experts or in the track lounge throughout the week, so more than happy to answer any questions that you may have. Aha. Okay, so what is serialization? Just to make sure you're in the right room, just to make sure that you're not interested in thread serialization or work serialization. So serialization is the transformation of some graph of objects into some stream and then back again. That's all it is, really quickly. Take some objects, stick it into a stream, get those objects back out. We have two technologies to handle this in the V1 stack, the V1.NET framework. That is system.xml.serialization, which ASMX uses underneath the covers, and system runtime serialization, which the remoting infrastructure utilizes under the covers. So, fortunately, we have one team that's now responsible for both of these stacks. They were developed independently for two different distributed application technology stacks. We've got our ducks in a row, and we have everybody in the world that works on distributed applications in one team. And our boss is here in the audience someplace. If I see him, I'll point him out so you can shake his hand. So we are addressing the serialization issues. A lot of people have come to us and said, oh my, we have two stacks, two different ways of approaching things. Help, help, help. And we said, we're sorry, we're going to fix that. And so that's what this talk is sort of about. Another thing that serialization does, other than transforming objects into a stream and then back again, is also taking a CLR type definition and transforming it into a type definition in another type system. And a great example of this is when you take a CLR type and you create a schema for it, an XSD for it. Furthermore, another example of this is when you take an XSD complex type or simple type and you transform it into a CLR type definition. So serialization is both of those things. Serialization and deserialization of instances and transformation of types as well. Now, system.xml.serialization is the current technology that handles this type transformation capability for us. System runtime serialization doesn't have that capability yet. And we'll talk about how that sort of gets into the model in a few moments. Serialization is a framework-wide feature. Web services use it. Remoting uses it. UConn even uses serialization. And you, as end users, can use it to your heart's content as well. Have some objects, want to put them on a disk, have fun. That's where serialization is there for you. Okay, so is everyone in the right session? Yeah. Yay! All right. All the enthusiasm. Great. Okay, so let's talk about serialization and WDB. Everyone knows about WDB, hopefully. It's the next version of the .NET framework that's coming soon to a theater near you, just after the next Star Wars movie, or at least after the Matrix movie. That's how I rate these things. Well, is it before the next Lord of the Rings movie or not? And then I plan accordingly. So, I have a very limited life. So I'm going to talk about the new features that we have in the existing serialization stacks, both the XML serializer and the runtime serializer. And then I'm going to actually demo a feature that we're going to have, and it'll be the only demo I do of Whidbey. Everything else will be demos of what we're doing inside of Indigo. So those of you that are currently building applications and are interested in what we have on tap for serialization in Whidbey, this is the list of stuff for you. And I'm going to talk about each one really quickly. First, we have a new imperative model for the XML serializer. Many of you are familiar with the declarative programming model that we have for the XML serializer. That's the thing where you put brackets on all over your types and you say, I want this to be an element, I want this to be an attribute, I want this to be a choice, blah, blah, blah. Whatever schema construct you'd like to have there. We support that in our V1 stack. A little known feature that's actually in the V1 stack as well is an interface called iXML serializable. This is the same sort of thing like iSerializable in the runtime serialization space. And what this does is it allows you as a type author to control not only the instance document that gets written or read for your particular type, but also the schema. And this was something that we released in the V1 product, as I was saying, but unfortunately it should have been called iXML serializable. It should have been called iSupport dataset. Because it really, in fact, if you implement it and you do a schema import, you may notice your type suddenly looks like a data set. And so a lot of people came and said, this is a useful feature, but I don't really want to look like a data set. I'd like my purchase order to stay that way, thank you. And so what we said is that seems like a reasonable request. So what we've done is we've introduced this as a first-class thing. We fully support it now, and you're free to implement that interface and control your schema and do your instance documents. Oh, thank you. See? Yes, we love you too. So, so that's the XML serializer interface. Now, another thing that people have asked for lots of times are, Doug, I have the schema and you generate a type for me, but I don't like your type. You guys just don't understand schema at all. I know it's so much better than you guys do. And we say, well, yes, you obviously do, because we're not good at that. And so, and we're working on it. So we said, okay, what can we do to give customers that want to generate programming models themselves? Like, a lot of people are very familiar with this feature of where you have a data set on one end, and you export it, and then on the other end, when you import it, you get a data set on the other side. And people start clapping. They go, yay, I got my data set over here. Well, what we said was, hey, we maybe should open that up a little bit and let everybody take advantage of that feature. What if I could have a purchase order on the server and then have the same purchase order on the other side? And so the technology that we use for the data set, the round trip, the programming model retrip, we expose as a public thing. It's called schema importer extensions. You plug right into our pipeline that generates types when we run XSD gen, and then you can go ahead and write out whatever type you'd like for a given schema complex type. It's up to you. So it's completely extensible. Have fun. You can have any programming model you'd like. Furthermore, one of the interesting things about the XML serializer that many of you probably know is that we happen to launch the C# compiler. You go in, you want to serialize a purchase order, and the next thing you know, you see csc.exe spooling up. And you go, oh my gosh, what's going on? And, that's a perfectly understandable reaction to that. So what we've decided to do is we're looking at some longer-term solutions to that, potentially IL generation, et cetera. But in the Whidbey time frame, what we've decided to do is we have a tool called SGen. It's very similar to a tool called NGen. What SGen does is it allows you to pre-generate serializers. So you can hand SGen a CLR type or hand SGen a web service or a web service proxy and say, hey, create me a serializer that can serialize these types or this particular parameters of this web service. And in doing so, we'll generate an assembly for you that you can deploy with your application, and then you don't have to take the startup hit of having us run code, generate code for you, and generate that assembly at runtime. Great. I told you they'd love that feature, man. Stefan is the dev lead for serialization. He's down here underneath the board. He's the smartest man probably here. So he's definitely the smartest guy I know, and so I'm happy to have him right here. Thank you for coming and supporting me. Okay. Furthermore, we're adding generic support to the XML serializer. You probably heard about generics. I'm sure Brad and many others talked about this. So you'll be able to have not an open generic, but a closed generic, an instantiated generic, in a web service. You can have list of foo, list of bar, etc. We'll fully support that. We obviously, well, not obviously, we don't round trip that from a schema perspective, but I'll talk a little bit more about how we can do that in the future. In addition, we support SQL types, which means we'll have a little switch on our XSD.exe tool that will allow you to generate SQL types for optional primitives. And so that's an interesting feature, especially with web services coming online from Yukon. Last but not least, I want to talk about the binary formatter. Now, this thing, version-tolerant serialization, for those of you that use runtime serialization or use remoting, you may be aware of the fact that when you define a foo, you have a type foo and say it has some fields on it, that once you mark that type as serializable, you can't change the fields. You can't add a field, you can't remove a field, you can't do anything to it. In essence, from a serialization perspective, your type has to become immutable. And so, interestingly enough, people would like to modify their types in future versions of their applications. And so we've taken that feedback, as reasonable as it sounds, and incorporated that into the serialization infrastructure that we'll be releasing inside of Whidbey. Furthermore, we'll be doing performance improvements and also supporting generics. So you'll be able to serialize open generics and instantiated generics as well. So the thing that I do want to show you in Whidbey, because I think it's actually really cool, is a thing called version-tolerant serialization that I was just referring to a few moments ago. And let me show you an example. As you can see, I'm running the wonderful operating system known as Longhorn. And I'm using this great development environment that I shouldn't see. Close your eyes. That shouldn't be there. Okay. What you see here is you see a person class, and it has a name and address field, and we have a toString overridden that's only for the purposes of the demo. So let's say that I built an application that had this particular type in it. I deployed that application. I saved lots of people instances off the disk or in a database or wherever it was, and I just have them sitting out there. So let's go ahead and do that. Let me just hit F10 really quickly to show you that this isn't demo fraud. And I serialize and deserialize, and everything's wonderful. I'll step into the code in just a few moments. But needless to say, I end up outputting a person.dat file, which I'll show you in just a few moments. So let's say sometime later I say, my application, I got some great customer requirements. They really want to track Social Security number. They really want to do that. So I go into my person and I say, oh, let's define, take the caps lock and off and be happy. Let's say public string Social Security number. Great. That should work, right? Now let's just say that I want to use a file that I already have out there. So let me go ahead and hit F10. And so I go and I step into my deserialize. I already have that file on disk. I'd like to deserialize into my person. So I new up a binary formatter. I open up a file stream. Then I go and I say, hey, formatter, deserialize this for me. What does it say? Oh my gosh, the formatter says, well, I think there's a version mismatch. I think that there are 3 fields on this type now, and I only have 2 on disk. Sorry. That's the end of the story. There's nothing you can do about that. You may say, oh, well, I'll just go and I'll implement iSerializable, right? That seems like a reasonable thing to do. The bad thing is that unless you were sealed, you can't. And the reason you can't, and the reason I'm losing my voice is because you would break anybody who had subclassed you. That's what interfaces do because, well, at least the iSerializable interface, because we have that constructor thing, right, that everyone loves. And so you have to chain the constructors in your inheritance hierarchy. So you cannot implement iSerializable. Okay, so how do we fix this, Doug? You've got us into this mess. Get us out of it. Fine. Fine, I say. So what we did is we came up with this wonderful new thing, if I could type. See, I told you I should have just, used something else, Stefan. I told him I should use copy and paste, but he didn't believe me. He said, you're such a proficient typer. Okay, so we've introduced this new attribute that you put on fields that you add in a new version of the type called optionally serializable. We're still taking suggestions for names. So if you'd like to come up and come up to the microphone and say, I think it should be named this, we're more than happy to entertain it. So optionally serializable says this. Okay, I am modifying my type. I'm adding a new field. You know what? I'm okay with the fact that when someone deserializes, this field might not get populated. That's one of the reasons we wanted to project this as a opt-in model. We wanted to require you to put this field here, and here's why. Unbeknownst to you, when we create an instance of the person, you may not know this, we don't actually run the constructor. We use a feature of the underlying serialization infrastructure called GUIO in some circles. It's a wonderful acronym. It stands for Get Uninitialized Object. What it means is we don't run into your constructors. Your field initializers don't run. So because of that, it may happen that you've got version 1 of person out there, and you deserialize into version 2, and you were expecting Social Security number to actually have a value in it, and it won't. So what we said is, well, it would probably be best if we went ahead and made people opt into this model. And so all you need to do is, when you add a new field, is add this attribute, which we may change the name of if we're open for suggestions, and then we let you then, watch me hit F10. So I hit F10, and something's supposed to happen. Aha, here we go. So I step in, I open up create a new binary formatter, open up the stream. Ah, success, it's wonderful. And you guys don't applaud because we're sorry we forced it on you in the first place. Okay. But we're into fixing our mistakes. So that's version tolerant serialization. What this means is that if you have an existing type hierarchy out there and you'd like to evolve that from a serialization perspective, you can't do it today, but in WIDBE you can. My encouragement to you is, for right now, until WIDBE ships, implement iSerializable. And I'll talk a little bit about that. We're going to be releasing guidance in a document that will come out in the next couple of weeks that prepare people for the new serialization world that we're about to reveal to you. And this will be part of that. So let me switch back. That was version tolerant serialization. I'm on time. So let's talk about serialization indigo. This is probably the reason you guys are here in the first place, right? Great. So let's talk about that. I think I'm going to have some more slides you may be able to read a little bit better. Let's see. Ah, just a little bit better. Can you see serialization down there? What I love about that is we're in the CLR. I was so happy when they put us in the CLR. I jumped up and down. I said, Stephen, we're in the CLR. We made it, baby. We're in the CLR. So I tell Stephen a lot of times, I say, hey, we've achieved assemblyhood. That means we have our own assembly, so I'm very happy about that. Okay, so this is the Longhorn architecture. If you see the base operating system, otherwise known as the boss, baby. So the boss is down here. We got the boss in charge. The boss is running the show, and serialization is inside helping out. So that's where serialization sets. And now let's blow this up just a second. Drill in a little bit on that upper left-hand corner. Indigo, indigo, indigo. It's a wonderful day. I woke up this morning, I said, I hope the sky is indigo. And it wasn't. I thought it was in the apocalypse this morning when I walked out. I don't know what was going on. Anyway, so what this is a diagram of indigo, the indigo architecture. I won't go into elaborate detail about this. Many other folks that are far better versed in the way that our architecture is set up can do that. Don does a wonderful talk surrounding this. But needless to say, if you look here at this yellow thing, not yellow, but rather red thing, it says message encoder. Message encoder is sort of a high-level architect-y speak for message serializer. And so that's where the serialization engine rests. It's part of the core infrastructure of the CLR, and it's also part of the core infrastructure of Indigo. So the serializer is everywhere. It's pervasive. It's always around and should be a part of your daily life. So this is sort of where we sit. I just want to level set and show everyone we're part of the boss and we're part of Indigo as well. So I want to tell you a story. The story is called A Tale of Two Type Systems. It was the best of times. It was the worst of times. Do you remember the rest? That's all I remember. Anyway. Yeah, something about XSD. Right, yes. So what I'm going yeah, it was the best of type systems. It was the worst of type systems. Guess which one I'm talking about. Okay. So A Tale of Two Type System is all about XSD and all about the CLR. Those are the two type systems that we're going to talk about. And so what you see over here on the left-hand side is sort of the scenarios that we were attempting to address in WIDBE, in Everett, and in V1 of the serialization infrastructure. And so if you look at the very topmost, you see XSD mapping into the CLR. In essence, providing a CLR programming model for XSD constructs. This is a very challenging thing. XSD obviously supports object-oriented constructs, but it also supports a lot of notions that are not object-oriented, which the CLR really is at its sort of core, the way that it does dispatch, etc. And so mapping XSD into the CLR provides some challenges for us. Now, taking the CLR and mapping that into XSD is somewhat straightforward to do. There are some challenges there as well, but it's pretty easy to take a set of CLR types and map them into XSD, right? Transform them, right? Project them into that other type system. And then going from the CLR to CLR, well, that's really easy, right? Well, because, it's in the CLR, so it should be easy to go from one to the other. Now, there are challenges around versioning. There are challenges around version skew, etc., with both types as well as the underlying frameworks, but it's fairly easy to do that, although there are some challenges there as well. Now, to address all three of these different scenarios, taking an XSD, mapping it into CLR, taking the CLR, mapping into the XSD, or doing CLR to CLR, we had three pieces of technology to help us do that. So we had the XML serializer, and what this did was it provided a CLR programming model for some XSD constructs. It did 60%, 60% good? Let's say 60%. Great. The dev lead said it was 60%. It must be true. So 60% of XSD constructs we could provide a good CLR programming model for. And we could also take some CLR constructs and map those into XSDs, as long as those CLR constructs had a public constructor and had public fields or public properties and weren't hash table. The serialization team giveth, they taketh away. Okay. We also had the XML formatter. The XML formatter was this thing that sat inside of remoting, and it was the thing that gave remoting its wonderful interoperable capabilities. Remoting had sort of this Janus thing. It was CLR and then interop, right? But not really, switch back on you really quickly. So the subformatter was the thing that could take some CLR types, mainly simple types, and map those into XSD, right? So if you had some of the XSD data types, section 2, and actually map those into XSD, it would do that. Furthermore, we had this custom SOAP encoding. So we could take a CLR object and we could generate some arbitrary abstract XSD for it, and it would have all sorts of CLR-isms inside of it. Needless to say, it wasn't literal. And then we had the binary formatter, and that didn't even know what the hex XSD was. All it cared about was CLR to CLR. And it was very sort of tightly constrained and tightly coupled. And so we had these three different pieces of technology that addressed all three of these different scenarios. Some addressed both, some addressed only one, etc. So it was really confusing to customers. They were like, okay, I have these different things that I'd like to do. I'm calling the whole space serialization, because that's really what we did. We said XSD to CLR, that's serialization. CLR to XSD, that's serialization too, and CLR to CLR, that's serialization. Oh, but it's one thing, but we'll give you three different things to do it with. So needless to say, people were a bit upset with us. So what we decided to do was, what is the resolution, what is Act 2? What are we doing inside of Indigo? Well, we just spent the last couple months taking a really hard look at the serialization space. And what we've discovered is, those three things that we showed you in the previous slide, they're really not the same thing. You can really break those up. You can bifurcate sort of that stack of serialization. And how you can bifurcate that stack is as follows. There's a thing called XML programming. And XML programming is all about, I care about the XML. I care about the XSD. I care about what's on the wire. I want to get at that stuff. And I want to deal with XSD. I want it to be in my face. I want to deal with the core atoms of interoperability and of web services. That's not serialization. Serialization is all about taking CLR types that people are writing, making those things interoperable, making those things loosely coupled, making those things version resilient. Serialization is about CLR. XML programming is about XML. It took us a long time to sort of reach this conclusion that serialization is about the CLR, about making that interoperable, about making that loosely coupled, and having another thing called XML programming that's all about on the wire. And both of these are extremely important to us. Making the CLR types interoperable and dealing with full fidelity with XML, both are incredibly important scenarios for us, and we want to have first-class support. But I'm going to drill down into this bottom bucket, and then I'm going to bubble back up and talk about how Indigo addresses both XML programming and serialization at the same time. Now, how we've decided to address the serialization chunk that I'm going to be discussing is via a thing called the XML formatter. This is the XML formatter architecture. It's at a very high level, and I'm getting ready to show you lots and lots of code on how you use that thing. So the XML formatter is a class that sits inside of system.runtime.serialization. That's the namespace in which it resides. It has its own assembly. As I said, we've achieved assemblyhood called system.runtime.serialization.dll. That's where it resides. On the right-hand side, you see sort of the programming models that people can utilize to write CLR types that can be used with the XML formatter. So we have this new programming model that I will show you called data contract. Data contract, the easiest way to think about data contract is how you expose data in the CLR in a service-oriented manner. right? You've heard Don hound everyone. You know, services, services, services. I feel like I could do a bomber moment and just scream services, and I would really lose my voice. But that's really what it's about. It's about service orientation. And this data contract model that I'm about to show you is about how you bring that to CLR data. But we already have a tremendous amount of types that are already out there, including the BCL, including all of the .NET framework, including pieces of WinFX, that already have a programming model. That programming model is serializable, bracket serializable that you put on a type, or iSerializable, the imperative interface for serialization. We did not want to leave those types behind. We wanted to take those types forward and make them fit into the services world, make them fit into this interoperable world, make them fit into version resilience and loose coupling. And so we've done that. The XML formatter, if you have types that are serializable today, we'll make them interoperable. We'll make them be version resilient. We'll make them be loosely coupled. We'll make them be service oriented for you. If you have iSerializable types, we'll do the same thing. And we have a new programming model that has some additional features that allow you to be even more explicit and even more service oriented in nature. Now the XML formatter has, needless to say, a class called XML formatter. It also has a thing called the serialization context. I'll show you these in just a few moments. If you have existing surrogates out there, many of you maybe have built infrastructures that utilize runtime surrogates, those will keep working. That investment, we're very keen on moving existing investments forward. That will work. If you have them today, those will just plug in. If you have type binders that plug into the binary formatter, the SOAP formatter, or your own formatter, that will continue to work. So extensibility is important for us, and also backward compatibility of those extensibility points. The XML formatter is about XML, but it's not about text. I want to hammer that point home. The XML formatter, we really should just call it the InfoSet formatter. But because there's already sort of a notion of XML, what that is, we labeled it the XML formatter because not that many people are familiar with the InfoSet. If you haven't read up on the InfoSet, I'd encourage you to do that. In essence, we operate at the InfoSet level, and you could have arbitrary formats for a given InfoSet. The InfoSet's an abstract data model. It defines things like element, attribute, but not the serialization format of those things. So what this means is that you want to support binary XML? Great. Our XML formatter works with it. You want to find your own format for the InfoSet? Great. It'll work with it. Any format that you want, as long as the abstract data model is the InfoSet, will work with it. Right? So XML does not mean text. You can have any format that you want as long as it conforms to that abstract data model. That's a key thing to get across. So when you see XML, it doesn't mean text. It means the InfoSet. So we support anything that you can have a concrete subclass of XML reader or XML formatter of, it'll work with it. Great examples of these inside of the existing framework are XML text reader, XML text writer. In WIDBE, the web data team is introducing an XML binary reader and an XML binary writer, and that will just work with this infrastructure as well. If you want to write your own, feel free. What this means is we support the full XML processing model with this and arbitrary representations, two of which the .NET Framework supports explicitly, and if you'd like to write your own, feel free. So in a nutshell, that is the XML formatter architecture. And now that I've bored you enough with slides, what happened there? Ah, okay. There's a demo. Whoa, boy, that slide went out of order. One of the things I do want to talk about before I jump into the demo is the serializable types themselves. So we do have existing types that are serializable and iSerializable. Those continue to work. We get you loose coupling, interoperability, versioning, etc. And we have this new programming model. But I'm just going to jump to code and show you everything because I think it'll be easier to explain it that way. Okay. So let me jump over, and I'm going to show you, first of all, the data contract programming model. So what you see here is, this is a class called person. The easiest way to sort of approach this new programming model called data contract is think in your mind about serializable, right? For a serializable type, you would go and you would put that bracket serializable on top of it, and then all the fields would sort of be serializable. And then, you just handled it that way. It was pretty simple. One of the big things that we discovered as we were developing this serialization infrastructure was that's really scary. That's really frightening. And the reason it's really frightening is the developer is not thinking about the fields and the data structures that will be on the wire. They're not thinking about the serialization contract that their type projects. They're not thinking about V1. They're not thinking about V2. They're not thinking about interoperability. They're just putting this bracket thing on there and they're saying, CLR, fix it for me, make it work. And so what we wanted to do is we said one of the core tenets of service orientation is explicitness, is saying what you mean, is not doing more, not having the infrastructure doing more than it has to or making assumptions on your behalf, but you as a developer saying, I am going to explicitly say what is part of the data contract that I project for my given type. So the easiest way to sort of approach this is to say, okay, I get rid of serializable on top of my type and I add this data contract attribute. And then for every member, the key in on that word member, that I would like to be part of the serialization contract, I will annotate it with data member. Now when I said member, I really meant it. I don't just mean fields, I also mean properties. And I just don't mean properties, I mean fields as well. So any member, including events, by the way, so both properties, fields, and events, you can annotate with the data member, and that will make it part of the explicit data contract of your type. So what you see me doing here is I have a person, I put data contract at the top of it. I say, oh, I'd like to expose name as part of my data contract as a member. Notice something about that as well. It's internal. We don't care about accessibility. We don't care if it's private. We don't care if it's public. We don't care. If you put data member on top of it, we'll serialize it for you. And that's one of the key aspects that sort of differentiates those two other stacks. So if you make this internal, we'll serialize it. You make it private, we don't care. You put data member on it, it'll be part of the data contract of your type. So you see me having the name here. I annotate it with data member. I have an age, and I annotate that with data member. And then you can sort of ignore this toString. Now the XML formatter has two modes. The default mode that I'm about to show you is tightly coupled. Tightly coupled means this. I care about CLR type. I care about the underlying type that I originally serialized. The XML formatter also has another mode called loosely coupled, which we imagine everybody will be utilizing, where you don't care about CLR type. What you care about is the data contract. What you care about is the service-oriented contract of CLR data. And I'm going to show you tightly coupled. You can imagine tightly coupled as being just like the binary formatter, right? Where you care about the CLR type information. And then I'll show you how that serializes itself. So I'm going to hit F10 here after I switch projects to show you that Stefan's team was kind enough to write a prototype of this particular serializer for this talk. And so we can actually hit F10 and everything will work. So we'll hit F10 and we'll step into our tightly coupled run. So you can see here I'm creating a person. I set it to Doug Purdy. That's my name, if you didn't know that. And my age is 99. I look rather young, I've been told. And then I new up an XML formatter. And then I'm newing up a stream. I serialize that person as you would expect. And then everything's fine. So let's go take a look really quickly at the file that I produced. I'll double click on person.xml, pop this out, and you'll notice a couple things here. One, I have person as a top level element. I have age and name, as you would expect. But I also have CLR type information there. I will increase the font if humanly possible. You want, how about that? There you go. So what you see here is I have embedded, or rather the serializer has embedded the CLR type information directly into the stream. What this means is that when I go back and I hit F5, we're actually going to do type get type and reload that assembly when we deserialize. So this is the tight coupling behavior that you expect from the runtime serialization infrastructure. So I'll pop back over here, and I will go and I will deserialize, and I will get the person back, and then I'll write the person to the console, and you can see that the serializer really works. So, you know, this isn't anything great right now what I'm showing you. In essence, what this is it's a newer version of the SOAP formatter in many ways, okay, what I've showed you thus far. And so you can expect that. You can say, oh, you know, great, Doug, whatever. Now let me show you the really wonderful thing about the XML formatter. So what I'm going to do now is I'm going to stop this, comment out the tightly coupled, and move into loosely coupled mode. And let me jump over and show you that example. So loosely coupled is this notion of where we really only care about the data contract, not the underlying CLR type. This is about bringing the notions of service orientation directly into the serialization space. So what you see me doing here is I have a person again. I've marked it with the data contract. Incidentally, you'll see me using serializable in a few moments as well. So I have person, then I've marked name with data member, and I've marked age with data member, and then I have my toString. Now, I want you to watch what I'm about to show you. You have to pay attention, otherwise it may quickly move away. I'm also defining another person here, which is another class. And if you'll notice here, I put data contract on it. But I give it a property value of person, right? What I'm doing here is, data contract is sort of this abstract platonic ideal of a service-oriented data contract, sort of this type description in the clouds. And how it works is, it's all about name comparison, nominal equivalence is a technical term for it, and structural compatibility, meaning that I have data members that are structurally compatible with each other. And so what I'm doing here is I'm defining another CLR type that has the same name, right, so I can get nominal equivalence as the type I had previously. If you'll notice here, I also am putting data member on this particular field, but notice that this is a field. It has underbar name as its name. But when I specify data member, I give it a name of name, which just happens to be the same thing as here. Right? Now if I scroll down again, you can see that I have a property called age, and I could call this anything I wanted, 65, 42, whatever. And I annotate it with data member, and I specify its name and its age. To the XML formatter, these types are exactly the same. There is no difference, because we match names, and then we compare structures, and then we can serialize and deserialize into either one. So let me show you an example of this in action. So I'm going to hit F10. I'm going to step into our loosely coupled run. You'll see me create a person, set the name to Doug, set the age to 99. I'll new up an XML formatter in data contract mode. Okay? By default, it's in tightly coupled mode. We call that common assemblies. The reason we made that the default was because we're very committed to taking existing customer experiences and knowledge and moving it forward. So the existing mode for the binary formatter is to be tightly coupled, so we decided to make it, the XML formatter, tightly coupled by default as well. So you see us creating an XML formatter. We new up a stream or create a stream, serialize out that person. Now I've serialized it out, and let's go take a look at what that looks like on the wire. So let me double click on person.xml and hopefully refresh. Okay. What you see here is, you'll notice there's no CLR type information in the stream at all. None. But you see that we've serialized person as the top level element with that data there. And now watch what I do when I deserialize. So I open up a file stream, then I have a generic, if you look over here, where I'm deserializing, and I'm specifying I would like to deserialize that into another person. So when I hit F10, boom. And I'm going to write that out, and what you'll see when I write out on the console is the following. Another person, it has a totally different type, it's a completely different CLR type. It doesn't matter, CLR type doesn't matter from a serialization perspective anymore. All that matters is this abstract notion of data contract. This is the ultimate in service orientation. This is what that's all about. It doesn't matter about implementation. What matters is we share commonality in terms of names and in terms of structure. And CLR type information just goes by the wayside. You can have an implementation, I can have an implementation, she can have an implementation, everyone can have an implementation, as long as we agree on what the name is and what the structure is. And this is the essence of service orientation. Thank you. Now, I want to show you even another class, just to prove I wasn't kidding. Here's another class called version person. You probably say to yourself, great, Doug, that's wonderful. I'm glad we can do these things. What about versioning? Well, you're about to see me have another type definition that's a future version of this data contract. Data contracts can evolve over time. It's a wonderfully open, version-resilient infrastructure. What I'm doing here is I haven't even stopped my debugging yet. I have another class called version person. I have data contract on top of it. I give it a name of person that makes it compatible with any other type that implements the data contract called person. I have name as a data member, age as a data member, and then I've added a new data member called social security number. Seems to make sense that I'd like to evolve my data contract over time. All you need to do in order to make sure that this versions is put data member on whatever new field you'd like, and then we ask that you specify the version in which it's added. And the reason that we need you to do this is not because it's a CLR-ism particularly, but rather it's a schema-ism that sort of bubbled itself up into our programming model. And this is how we can get XSD schema versioning, which I'll show you examples of in just a few moments. But needless to say, you can add fields. I'll actually show you with the schema how this manifests itself in a few moments. But you can see you can add fields to your heart's content. And if I hit F10, you can see here that I've taken person, serialized it, deserialized it, which I showed you. Now I'm going to deserialize it into another CLR type that implements the same data contract, but it's an evolution of that data contract, right? This is a backward compatibility scenario I'm showing you right here. I'm going to hit F10, and bingo, it just works. What this means is you can take, over time, arbitrary implementations that vary, as well as data contracts that vary over time. As long as the name is the same and the structure is compatible, it just works. And so that is the essence of loose coupling utilizing the XML formatter. Now what I'm going to show you next is another set of features that lots of customers have asked for in terms of being able to participate in the serialization process itself. So what you see here is a person called inquiring person. This is a person who wants to know. And so, what we've done is we have a person that has data contract on it, and then we opt in this particular member, which is name, and that's it. And then you'll see that we define a public constructor. The only reason I have a public constructor is so I can new it. We don't require that. But notice this right here. I have defined a private constructor that happens to take a streaming context, which is a class that's shipped in V1. If you provide a constructor that has this signature, we will call it for you. We'll say, oh, this is a class that wants to be notified about deserialization. They specify this constructor. Let's call that particular constructor. We don't care if it's public, private, whatever. We'll call it for you. And that's how we'll construct your type. Furthermore, lots of people have told us, hey, can you please call me when you're deserializing me? I got work I have to do. And we'll say, yes, that seems reasonable. And so in V1, we provided a thing called iDeserialization callback, which is an interface you could implement, and then we would notify you. The problem with this is interfaces are a wonderful thing. We love interfaces. But in terms of how you evolve a type hierarchy over time, let's say that I have base and I have derived, and I'd like to evolve those over time, interfaces aren't too great of a mechanism in order to enable that, at least from an infrastructure perspective. So what we decided to do was have a number of attributes that you could annotate on methods, and this would allow us to know what particular method you would like to be called rather than implementing an interface. Versioning is something that Stefan and I spend late nights up thinking about because we really want people to write a set of types and then not have to bang on our door and say, oh my gosh, you guys didn't think about this problem. We want you to be able to have a core set of types and then be able to evolve those over a given length of time. And so this is part of that sort of thinking that we're doing. So here's where you can be notified about deserialization, both when you're deserializing as well as being deserialization complete as well as end time, and then on deserializing and then on deserialized. So let me hit F10 here, or actually just continue my F11ing. Is that a verb? It's a great verb. And then we step in, and you see that I'm newing up the inquiring person, and then I say person name, I'm setting that, and then I new up an XML formatter, and then I go ahead and I serialize this thing, and if I step in, what you'll see happen is, boom, it calls on deserializing to notify you that it's being deserialized. Then I step in, hopefully, and something amazing should happen and not hang like that. Oh, my. Oh, is it selected? Oh, man, you guys, I don't know what I'd do without you. And so then we set the name. We finish there, and then it calls on deserialize complete. Now I'm going to step out of that. Now I'm going to deserialize. Then you see us calling the constructor. We'll notify you there. Furthermore, then we'll call your on deserializing whatever method that is. And then once you get finished, we'll do the set first, and then we'll finish up by calling on deserialized. And boom, you're done. And so what this means is you're involved in all the various steps of serialization as it occurs. Both when we construct the type, when we're setting values, when we're pulling values out, you can do anything you'd like to do. You like that feature? Wonderful, thank you. This is I'm about to show you the feature I'm the most proud of, well, probably second proud of. Once you see the interop story we have, I'll show you, that's the one I'm most proud of. But this backward compatibility that I'm about to show you is something we labored on for weeks and weeks and weeks and months and months and months to bring a great backward compatibility story to existing types that are out there. And so let me show you an example of this. What I have here is I have a serializable class called Citizen. It has a name. It has an address, and because it's serializable, that means I don't have to put data member or anything on it. It just means all fields that aren't marked with that wonderful not whatever serialized attribute will be part of the data contract of that type. You'll see that I have name, then I have address. Address is a complex type. Notice this. The address isn't serializable. It's data contract. Notice that it has a member that has string, right? And then if you'll come down here, you'll see that I have a serializable type called Canadian address that's a subclass of address that's serializable, but its base type is data contract. What this shows is that you can fully compose and fully inherit all these things to your heart's content, and you can use types that you have today, use them with the XML formatter, write new types that have data contract, use those inside of your data contract or serializable types. We don't care. Compose them, inherit them, use them as you will. And now I'm going to show you, I'm going to step into that example. I'm creating a new citizen. I'm setting the name to Jan Gray. I don't know how many of you know Jan Gray. He's the wonderful CLR performance architect. And when I was thinking about Canadians, his name came to the fore. So he lives in Canada, or he comes from Canada, but he lives here. So I'm newing up a Canadian address. I'm setting that address to have a street of Microsoft, 1 Microsoft Way. I'm setting his favorite province to be British Columbia. I'm setting that onto the citizen itself. I'm newing up an XML formatter in data contract mode, serializing this thing out. Now I'm doing something very interesting. The XML formatter is very similar when it's in data contract or loosely coupled mode to the way that the XML serializer works. If you remember, the XML serializer didn't care about CLR type information. What it cared about was queue name, right? It cared about the queue name that was on the wire and the queue name that a particular type would project for itself. In loosely coupled mode for the XML formatter, it's the same sort of thing. We need to know the universe of types, right? The universe of types in which we know how to deserialize. And so there are many mechanisms for you to get types into the universe of types. One is to specify, if you look right here, specify the type when you're deserializing. Many of you are familiar with this with the XML serializer. Another one was to specify in XML include on a bracket a particular thing, or to provide an array of types during deserialization. Because we know lots of people want to do lots of things with this loosely coupled data contract mechanism, we also provide a thing called serialization context. Serialization context, you can think of it like call context or execution context or HTTP context. You get to it via the current property, which you'll see here. And so it's always in scope. You can just say serialization context.current to get the most current one. And then we have a collection on it called known types. These are types the XML formatter knows about. And so you can add types to that particular collection, and that lets us know how to deserialize them. Incidentally, we also populate this known types with lots of types ahead of time for you. Lots of people had a lot of complaints with the XML serializer because they would say, oh, I want to deserialize this type, but it's not in the universe. What do I do? And so we have a mechanism that actually allows folks to plug in via the programming model. Furthermore, we have a default set of types in the universe, which includes lots and lots of types from MS Core Lib, so you don't have to worry about actually placing them in the universe of types. So you see I'm adding Canadian address here so the serializer knows about it, and then I'm deserializing citizen, and everything just works beautifully. So what you see is serializable works, inheritance works with serializable, data contract works with serializable. All your existing investment in serializable types just keeps working as you move forward to Indigo. Yes? Why do I cast it to citizen? I don't have to. Good catch. I don't have to. It was a demo bug. I admitted one. Rate it for me. Put it in a rate. I need to fix that. Yes, you can. So I will jump down and I will show you citizen. Citizen has, if you'll look here, we have citizen. It has address, XSI type, which is what you would expect. Then you see street, and then you see this type delimiter thing. I'll get to that in a moment, what that is. And then you see the province, and then you see Jan Gray. So it's a reasonable looking XML that you would expect to see produced for serializable types. Great. All right, so let's talk about XSD support. I'm sure everyone's like, yes, that's great, wonderful, interoperable for CLR types. What about my XSD? I love my XSD. Show me some XSD, Doug, please. You will not walk away from this talk disappointed, I promise. All right, so every serializable type, if you put bracket serializable or implement iSerializable or put bracket data contract on your types, it is interoperable. Interoperable. It will work with WebSphere. It will work with BEA. It will work with anyone who understands XSD. We can generate a schema for every, let me repeat that again, for every CLR construct, including generics, including events. We know how to produce XSDs for those things. So we can export valid XSD for any CLR construct. For even hash table, I'll show you an example of hash table in just a moment. I should have said no, not hash table. We couldn't figure it out. We're banging our head. Hash table, I can't go to PDC and not, we don't, yeah, it's really hard. Anyway, so I will show you hash table. We have, well, I'll show them kind of. Anyway, so I won't show you F10. I won't show you F10 with hash table, but it will be there. Anyway, so our mapping is not extensible. What this means is that when you have a CLR type that has data contract or serializable or implements iSerializable, we have a canonical mapping for those CLR constructs. We say, okay, we know how to map an event. We know how to map a generic. We know how to map iSerializable. And so you get our mapping. And it's not extensible in V1. That's something that we're taking a hard look at. Mapping is important to us, but our current plan of record is that mapping from CLR construct to XSD is not extensible. Now, you may say, great, Doug, I'm glad every type that I create that is serializable is also interoperable. That's wonderful. I'm glad to see that so I'm putting words in your mouth. That's great. Now, what about all my XSDs? I'm one of those people who doesn't like to do code first development. I like to do schema first development. What do you got for me? Huh? I don't want to walk away from this talk with nothing. So what we do have is we support every XSD. Any XSD in the world you can think of that you can do and key ref and redefine and this and that and wonderful. It's awesome. We support it. Substitution groups, yes, yes, yes. We support that. But let me talk about how we support that. And this is really fundamental. Remember, we bifurcated those two problems, right? We said in V1, serialization was all three of these things. Taking XSD, making it in the CLR. Taking the CLR and putting that in XSD, and then doing that CLR to CLR thing. The XML formatter is a serializer. It is a serialization engine. It is not an XML programming model. Serialization is not XML programming. XML programming model, XML, whatever. XML programming is not serialization. They're not the same thing. We took a hard look at this. It was so hard. We tried so hard to make serialization XML programming. And we tried to make XML programming serialization, but we just couldn't do it. We didn't have enough hair. All that energy was just going away. So what we've done is, the XML formatter is a serialization engine. So we have a canonical mapping, much like we have a mapping that goes from CLR construct to XSD, we also have a limited set of XSD constructs that we can map into CLR. So we have this canonical mapping, we can take these XSD constructs and attempt to map them into the data contract or the serializable programming model, but quite frankly, a lot of them you just can't force into that model. And so what we said was, rather than trying to create some convoluted programming model, which I'll get to in a moment, that does that for serialization, we would just split these stacks and we'd say, okay, serialization is about interoperability of CLR data, it's about projecting good schemas, getting loose coupling, getting service orientation for CLR data, and over here is, okay, you guys are the XML programming side, you guys are the serialization side. So that's what serialization is about. And XML programming is all about, I care about my XSD. I care about my wire format. I want to control it. Get out of the way. And so what this means is, the XML formatter is for this side of the house that wants to do CLR data in an interoperable, loosely coupled, service-oriented way. And this side of the house, we have wonderful, wonderful XML programming models for you to utilize. One of those wonderful XML programming models is the XML serializer that we shipped in V1. It has a good programming model for manipulating XSD and manipulating XML. Furthermore, we have another great set of APIs that are coming out in WIDB and in future releases, like XPath Navigator. And then, of course, you have XML Reader, XML Writer, and lots of other potential programming models that are out there. And you can even create your own. But these are sort of separate things. And let me show you how that manifests itself when you utilize Indigo. All right. So what I'm going to show you here first is I'm going to show you XML formatter producing interoperable XSD. Remember I said every CLR construct that is there, we can produce a valid XSD for. So we'll have a tool called XSD Gen. XSD Gen, or rather DC.exe. We changed the name like 5 minutes before I got up on stage. So we have this tool called DC.exe. And what you can do with that is you can run that over top of a given assembly, and it will produce valid XSD. And so what you see here is XSD for those types that I showed you previously. In all the demos that I showed you previously, this is the schema that we would produce for those things. So one of the things we do is we always produce a GED for a given type, and it's always typed to whatever the data contract type is. And then we always have one complex type that is defined with the same name. So if you see here, you'll see that I have a person, which I defined previously. You'll notice also that I only have, for every data contract, we only export one particular schema construct. So you see here that I have a global element decal, name person, type to person. And then here I create a complex type that's called person. And you'll notice a couple things about it. One, it has a sequence that's min occur 0. And then I have elements, or particles rather, that are inside of that compositor that are ordered alphabetically. And that's sort of the canonical mapping that we have. We look at your fields and we say, oh, we'll alphabetize those for them, and that's how it'll go out over the wire. You don't have control over that because we have a canonical mapping, and that's just how we export CLR types. It's a valid XSD. It will work with any other potential web service system, but it's our canonical mapping. Now, previously I said we want to do versioning. Versioning is very, very important for us. So I'm happy to announce that we figured out how to version schemas. So this is how that will work. So what we do is for every CLR type that we export, we end up adding a group at the very bottom of it. And we call that right now unknown data. And what that is, that's a min occurs 0 with a max occurs unbounded. And let me jump over and show you what that is really quickly. So there's a schema that when we export a given CLR type, we'll always include sort of elements and schema constructs from this particular namespace. Let me scroll down and I'll show you the definition for unknown data. What unknown data is, a lot of people say, okay, how I want to version my complex types is, and I talked about this at TechEd as well, is I want to put a content model, an open content model at the very end of my complex type. And that allows me to add things willy-nilly to that as need be. Now, one of the downsides to that approach is that when you have an open content model, you lose typing afterwards. You put the any at the end of the complex type, and then, well, anything goes. Any type can be there. And so lots of folks came to us and said, oh, well, that's really interesting, Doug. I'd really like to have strongly typed schema constructs after that. And we spent a lot of time thinking about how you can actually do it. And I'm happy to say that we figured it out. We'll be actually publishing a paper on how to do this so people can prepare for when the XML formatter and when Indigo come out. But this is how you do it. What you do is for every complex type, you include an element that's in a different namespace, this namespace being the serialization namespace that we have, and then you declare an any at the bottom of that, right? So it's a standard open content model. Now the reason that you have to declare things exactly like this, and the reason that we have a particular group for that, is if you come down here, and I'll show you an example of me versioning person. In essence, what this is this is the same definition as person above. Ignore the fact that it has a different name. Just consider it person. You'll notice that it has the same exact declarations. It has the sequence, it has age, it has name, and then you'll see, in place of that unknown data, you'll see a min occurs 0 sequence that then has that version delimiter that was defined in that group, and then has the new field after it, followed by that unknown data group again. What in essence we're doing is, we have this any, and an any is like a black hole. If you try to put optional elements at the, following an any, they just happen to fall in the any, and it becomes a non-deterministic schema. What we figured out was, we found a way to seal off that any, and then provide strongly typed particles following the any, and then place another any at the bottom of that, and limit the scope of that black hole of the any. So what this gives you is the ability to add fields all day long to your particular complex type, to have an open content model, but also retain strongly typed particles as you version your complex types. And we provide that to you by default. All you need to do is put data contract on your type, and when you add members, put that version added. This is the key thing. The reason that we need you to put version added is so we know where we need to insert this particular element, or rather this particle, inside of the schema. And so that's what that's there for. So we figured out the way to version schemas to get nominal equivalence and structural compatibility, which is the thing that we talked about for service orientation, from schemas. You don't change the namespace, you just evolve the complex type that you have. And so we take care of that for you. So this is the GEDs, and I've showed you versioning of person. And also what we have is a thing that we also add to every type that we export is a thing called type attributes. That's an attribute group, and let me show you what that is. This attribute group defines a couple of things. One, it defines CLR type, which is optional, which is, here's the key thing. When you're in tightly coupled mode and in your loosely coupled mode, the schema that we produce for both of those is the same. Furthermore, every instance document that we produce both in tightly coupled mode and in loosely coupled mode validate against the same schema. Right? That's a wonderful thing in terms of you can have tightly coupled instance documents out there, and they will validate fully against the schema that you produce for a given type. And so we have CLR type here, which is an attribute we'll insert inside of the element. Furthermore, one of the things that we'll be supporting is literal multi-ref. So this is a feature where we'll have a knob that you can turn it on, and then you can maintain referential integrity of your instances in a given graph. And we'll allow you to support that with a knob. But it's fully schema compatible. You can schema validate against it. It isn't SOAP encoding. It's all literal. We just have a mechanism to provide that. We figured out how to do multi-ref with schema in a schema valid way, and we figured out how to get CLR fidelity in a schema valid way, and we figured out how to do versioning in a schema valid way. And all of those things are interoperable. That's very important for us. And last but not least, one of the core things that we do for schema is we also, in a given instance document, we'll track the base types. One of the big pieces of feedback that we had was, hey Doug, I have a particular instance document, and I don't have the type definition on my machine. I have the base type definition, but I don't have the derived type information that the instance document particularly says it wants inside of XSI type. So what we provided is the ability to track the base hierarchy, and we can say, oh, you know what, you may not have that type, but you have its base type. Deserialize into that. It's lossy because you lose the data for the derived type, but it means that you can still operate on types that you do share in common. And so this is a wonderful sort of mechanism for folks. They can have commonality at a higher level and then have instance documents that are derivations of those, but communicate in a loosely coupled fashion as well. Okay. So now I'm going to show you a WSDL. So that's great, Doug. What you've shown is you've shown how I can get an interoperable projection of any serializable type. How I can take any serializable type that I write and make it interoperate with other folks in a loosely coupled and version resilient way. Great. Now, how do I, as an XML programmer, how do I interact with the system? Okay. So what we have here is a WSDL. It's a WSDL for an accounting system. Let me drop down. I don't show the actual bindings, but I will show you the port type. So the port type here is accounting port type. It has three operations on it. One is add book, which takes an accounting book and adds it to a collection. The other one is add books, which takes a collection of things. And then delete book, which just deletes accounting books. So think of this sort of as one of those ledger systems where you can add an accounting book, add multiple accounting books, and delete books as you'd like. And if you look at the message definitions of each of those, I'll show you those. You'll see one here at the very top level that says element name books. The type is MS:* hash table. I wonder what that is. Well, it just happens to be the exported schema, if you look here, the exported schema for system collections. Because we can produce interoperable schema for every CLR construct, every CLR data construct, that means hash table can be interoperable. We actually will export a list of dictionary entry. And that is what the schema is for hash table. List of dictionary, unbounded list of dictionary entry. And so that's what this is. Books is a hash table that's a schema type, and everyone can use it. Everyone can program against it. If you look here, you'll see that I have accounting book, so books is the message for add books. Accounting book is the message for add book, which is the singular rather than the plural. You'll notice a couple things about it. First, it's the element name is accounting book. Inside of it is an anonymous complex type that contains an attribute. These particular schema constructs are not mappable to our data contract programming model. We don't support anonymous complex types inside of data contract. I'm not saying we don't support anonymous types. What I'm saying is when you have a schema that has an anonymous type defined inside of it and you attempt to produce a data contract programming model, we say, oh, we don't know how to map that. We're not going to produce a data contract. But it doesn't mean that Indigo doesn't support it. It supports it in a first-class way, and I'll show you how it does in just a second. And then if you see here, you see that I have delete book. Delete book is the message for delete book, obviously. So I have an element with name delete book. Inside of it is a complex type with a sequence compositor that has an element and then a choice of sequence and element. Okay? Just keep those things in mind. All right? So that's sort of one of those things that if you knew what the XML serializer did today, you know that it would just fall down and die a horrible death. All right, so what we have here are three different things. We have hash table, we have accounting book, and we have delete book. Now imagine we had a tool, which we will have, called WSDLGen, and imagine it had a slash server switch. Those of you that are familiar with WSDL.exe know that there is a slash server switch that allows you to define a schema, define a WSDL, and then bring that into the CLR and produce a web service that you can then implement. Okay? This is the scenario that I'm about to show you. You're a schema-first developer. You're an architect. You define your schema for the developers that work for you. You hand them that schema and you say, program against this. Create me services that use these schemas, that use this WSDL. And so they would use the tool WSDLGen.exe, do slash server with the wonderful WSDL that you've written for them, and this is what they would get. They would get the following. This is the wonderful, I think Don Box covered this today, the wonderful service model programming model. And what you see here is the following. So we imported that accounting port type. We generated an interface. We created an interface. We annotated that with service contract. And then we created three operations. We had three operations in the WSDL. Seems to make sense that we have three operations in the the interface for the CLR. What you see here is as follows. You see us producing an add books, and look at this. It just happens to notice the fact that you had a hash table that was list of dictionary entry and give you a hash table. And the reason it gives you a hash table is when you do schema import, we have a whole set of schemas or actual CLR data types that we know about on import, and we say, oh, here it comes. I know what that is. Give them what they wanted. They wanted a hash table. Give it to them because we know the schema for that. Then what you see here is if you remember when you saw accounting book had the schema. The schema for accounting book was utilizing an anonymous complex type that had an attribute inside of it. And as I was saying previously, that doesn't map to serializable or to data contract. And what we end up doing there is, this is how the process works. We take a scheme, when we import a WSDL, we grab each of the elements, right, that are defined inside the message, and we hand it to our schema importer, and we say, hey, can we get an XML formatter programming model for this? Can we get bracket data contract for this? And we ask it, and we say, no, we can't. If we can, then we produce it, right? We look and we say, yeah, we can produce it a data contract type. Boom, there it is. Hash table's a data contract type. It just works. But then we say, oh, you know what? It has this anonymous complex type. It has an attribute inside of it. We don't know what to do with that. So what we do is we then hand it off to a strongly typed XML programming model. What this means is this is a mechanism for you to get dots over XML. I talk about that a lot. It's the ability to take elements and attributes and do dots, which is a method accessor inside of the CLR. And what we do is we say, oh, we don't understand that schema, so what we're going to do is we'll produce a strongly typed XML type utilizing the XML serializer programming model, which is our strongly typed XML story with Indigo. So what you see us doing here is we produce a accounting book that utilizes the same attributes that you're already familiar with. It has XML attribute, XML type, XML root, etc. We'll create that type and then allow you to program directly against that as you would in an existing web service. The only distinction is this XML element attribute, which tells the underlying service model architecture, this is strongly typed XML. This is not serialization. You've jumped over into XML land. You care about the wire format. You care about the schema. And this tells the infrastructure that. Now, what about types that the XML serializer really can't make sense out of? And those do exist in the wild, as many of you may know. So what we do in our process is we say, oh, can we fit this inside of the XML formatter? Great, generate. If not, hey, can we fit this into our XML serializer? Great, generate. If not, uh-oh, we're really in XML land now, Dorothy. And so what we do is we say, this person really cares about XML. They really love it. So what we're going to do is we'll give you the message. There it is. Take it. And onside a message is XML reader. And you can do anything you want with the XML reader. You can deserialize it with the XML serializer. You can put an XPax navigator on it. You can put whatever programming model you want on it. There's your XML. It is there for you to love and to cherish. Here's the thing, too. If you don't care about data contract, if you don't care about serializable, you say, look, Doug, that's great. I love all that stuff, the hash table, whatever. We'll have a switch that says, I'm an XML head. And all we'll do is produce message. So you'll have strongly typed operators, but you'll just get the message. For everything, you get a message. And so you can operate in this wonderful world where you just deal with the XML directly. We get out of the way. So what this means is, if you're a serialization user and you care about interoperability, you care about projecting CLR types out, we've got a great story for you. If you're one of those people who cares about XML, we've got a wonderful story for you as well. And we're going to continue to evolve both of these programming model experiences as we move forward. Serialization will continue to get even more interoperable. I don't think it can get any more. It'll stay interoperable. We won't change that. Can't get it anymore. It's 100%. Can we do 110? He's better at math than I am, so I don't. Anyway, so that's the story that we have. So let me jump back, and I'm run over, and I'm sorry, but you know what? I'm the last talk, so. All right. So moving to Indigo, this is really important, right? So Indigo, the best way of thinking about Indigo is if you're a remoting person, Indigo's V2 of remoting. If you're an enterprise services person, Indigo's V2 of enterprise services. If you're an ASMX person, it's V2 of ASMX. Ha ha ha! Everybody's happy. So if you use either one of those three products, or even WYSI or MSMQ, it just is wonderful. It's so wonderful. COM isn't love. Indigo is love. Indigo will work well with existing systems. If you have WYSI, if you have ASMX, it'll just keep working. So existing applications have a very easy migration path to Indigo. Joe Long is going to talk about, you have to go to Joe Long's talk. Get there early, camp out, be there at 7 a.m. because seating's going to be tight. He talks Wednesday at 12. The key thing I want to talk about, you should camp out right now. Existing serializable types, existing serialization extensibility points, those just keep working. We have a wonderful backward compatibility. Indigo's got a super high backward compatibility bar. Serialization has the highest one in Indigo. We just support any type you have out there, it just keeps working. So, also, you need to follow our prescriptive guidance. Joe is going to go into great detail on how you modify your existing apps, or how you architect your apps utilizing our existing technologies to get ready for Indigo. You need to go to his talk. If not, you need to read his slides on ComNet. It may be one of the most important talks, other than this one, that you go to. We will be releasing, as I was saying, prescriptive guidance about serializable types. I will send out email. That'll be on my blog, which I'll share with you in just a few moments, and we'll get that information out to you. Okay, let me talk really quickly about the PDC bits. I've showed you a wonderful story here today. At least I hope you think it was wonderful. We talked about some of the WIDBE features. 2 of those are available. The coding for the rest are being done. So IXML serializable is done. SQL types is done. We're still coding the other ones. We're getting ready to lock down the final milestone as we speak. Those will be available soon. Inside the Longhorn bits, there's a thing called system.serialization. System.serialization is the successor to the XML serializer. It is yet another XML programming model. It is not a serialization engine. It was an attempt on our part to try to get more than 60% of XSD support in the CLR. Well, we ended up discovering, and do that in such a way that you didn't have to understand XSD. It was, here's XSD, here's the CLR, we give you this thing where you don't have to understand, XSD at all. What ended up happening was, in order to support 100% of schema, we created a third thing. So you had to understand XSD, you had to understand the CLR, and you had to understand this thing that Doug created, which was scary. And so it just didn't work. We learned so much from doing it. I think we support, 90% of schema in there, maybe 80? 96% of schema is supported. But the problem with it is that it attempted to be that box, that big box, right, that shows XSD to CLR and CLR to XSD and CLR to CLR. And it just didn't work for us. And so we really got a lot of invaluable lessons from that. Number one lesson, discovering that XML programming and serialization are 2 totally different things. They're just different. And we're going to fix both of them, by focusing on what's core about them. So this will likely not ship with Indigo. That's the current plan of record. It may. I'd encourage you to still take a look at it. It supports 96% of schema, but you may not comprehend how it does it. Okay, so here's some more information. Email me anytime. I promise you I will get back to you. It may be next year, but I will email you back. My blog is always up there. I will talk about serialization from time to time. Please read it. I'll talk about serialization. Please go to the Longhorn Developers Center. There's the name, the news groups. You need to go there. There'll be lots of traffic. We love to talk about serialization there. And I'll always be available at the foyer. So this is the close. The closing thing is this talk in a nutshell. So in Whidbey, we are delivering great evolutionary features on the existing serialization stacks. But in Indigo, we will provide a unified serialization engine. The key thing is serialization engine, not unified XML programming model, but serialization engine that gives you interoperability. We're completely interoperable, backward compatibility, version resilience, as well as super high performance. That's Stefan's primary mission in life, is to be so much faster than the existing stacks that it's really frightening. So we support as many XML programming models as you can possibly imagine. If you want to deal with it, you can deal with the XML all day long. We will get out of your way. And we know that people love XML. We love it too, and we want to give it to you in a first-class way. And we need your feedback. I'll stand up here and answer questions until I'm blue in the face or my hair grows, and I'll be in the foyer if you want to talk to me there as well. Thank you. If you can, you need the mic. If you guys can go to the mic, I will answer questions. The mic's right here in the center. Thank you.
I'm sorry? Do you support nillable value schema that has nillable value types that map to valuable? I'm not explaining, but you have an issue with the previous version that if you have a schema definition that actually maps to value types within the CLR, and you define this element as nillable or as optional, actually when you deserialize as a value type, it always gets the value 0, for instance, for an integer or for a datetime.
So the question is, they talked in the mic, so I don't have to repeat the question. The answer is yes, and we will support that via SQL types. So SQL types have a first-class notion of nillable. We also are introducing a new thing in the CLR called, is it nillable now or optional value? Nullable of T. And so there'll be an option with XSD.exe of where you can specify that I'd like to generate a generic that is nullable of T, and then we'll do that for you.
So is XSD.exe going to be enhanced at all to have more support for array lists rather than arrays? Just a number of other enhancements to the programming model that's generated. In the case of your right side there, where you want to be explicit with your XML and define schemas.
The answer is yes. We're doing some of that inside of Whidbey. Furthermore, we now have the extensibility hooks where if you don't like what we're producing, you can certainly plug in and change it. So if you don't like we're producing arrays, you can produce an array list. So it's fully extensible, plus we're making changes like we're talking about producing generics in some cases, as well as properties instead of fields for data binding. So we're taking those on an ad hoc way, but I think the core way you can address that is, here's the extensibility hook. If you don't like the way we're doing it, change it.
Okay, so you can customize it totally with the extensibility. All right.
Yes.
So when you demoed the imperative approach with the on deserializing, and so on and so forth, couldn't help but notice that after you got through those events, the values were still being set by the runtime in the fields. Can we make it completely imperative?
Okay, so we fully support iSerializable.
Okay.
Now the issue with iSerializable is a couple. One is that iSerializable, we've decided that declarative serialization, one of the reasons people want to use imperative serialization is they want to run code. Right? That's one core reason is, hey, you're just getting my fields, I want to run some code. Whether it's setting values, doing something, or what have you. In the data contract programming model, we support properties. And because we support properties, codes runs. So you can do anything you want inside of the property setter and getter. We will support iSerializable, but the problem with iSerializable is the schema for iSerializable is always the same. The schema for iSerializable is hash table. And so you can be fully imperative, we'll fully support that. But there's two issues. One is schema export, because we export use the hash table. Furthermore, there are versioning issues associated with iSerializable as well. And so we're taking a look at other mechanisms of potentially doing imperative, but it will probably be property-based in some way, shape, or form. So one of the ways you could simulate iSerializable with properties is have a single data member that was of type hash table. And then you would just return that, and then properties would run. Or you could implement iSerializable, but you probably want to do the data member having hash table just so you avoid the versioning issues with iSerializable. But there's not a new imperative mechanism inside of data contract.
Kate?
Hi. I have two questions. One is the sample schemas generated from the CLR types had the namespace, target namespace, which looked funny. I mean, so what are the rules how they're generated?
So let's take a look. Is this what you're referring to? Which target namespace? This one?
Yes, exactly.
Right. So what we do there is, if you'll notice, that is the namespace, the CLR namespace in which those types reside.
Oh, that's yes. But in the instance, it was like Microsoft.com, and then it had year and the month.
Oh,
So
yes. What that is that's this particular schema here. That's the SIR schema. So,
oh, it was the target namespace. But okay, it's probably yeah.
So what we have is we have a kind of. Oh, I can go to the instance document if that's what you're referring
Yeah,
to.
just open the instance.
So what you see here is by default, unless you specify the namespace, what it will do is it will do schemas.microsoft.com, and then it has the namespace in which it resides.
Oh, so oh, I see.
See? So what we do is we look at the CLR namespace, and then we modify that, make that the target namespace, and use that moving forward.
Right. So
And this will also be tunable as well. One of the things I didn't show is if you want to specify your own namespace, you can do that both at the type level and at the assembly level.
Nice. My second question is about modularity of the code, C# code that's generated from the schema. For example, if I have the base schema definitions that I want to generate my data contract members, and then I can take base schema definition, generate data contract members. I can write a bunch of helper code that helps me to deal with these data types, do certain stuff on them, on top of them. And then I can write another schema that defines new service that reuses the objects from the previous schema. So if these are two different teams, development teams owning the base schema and the schema that uses it, it's very likely that base code that's derived from the base schema is maintained by one developer and it's one DLL.
Yes.
Another code is another DLL.
Yes.
And if you always generate types for all the schemas, including base types, then it becomes a problem because for a second development team to reuse the helper libraries written by the first development team.
Yeah. So your question is, how can I reuse the implementation I already have of that particular schema that has my helper functions inside of it?
Yes, when you're going from XSD to...
Yeah, so we have a part of XSD, or DC.exe, the new XSD.exe, is a feature called /R. What that lets you do is we say, oh, okay, I'm importing a given schema, and I'm doing it QName by QName, right? And I say, okay, I also have these assemblies that I know about. During the import, I'm going to match them, and I'm going to say, oh, just return that type, just return that type. So there you go. /R. Yes. Yes. That's how we do hash table. So when we see the hash table, when we see the hash table come in, we go, oh, we already know about that. Just give them back the hash table.
I have a question on the XML formatter. Is
Yes.
that already in the bits, in the PDC bits?
No, it is not in the PDC bits. It's part of the milestone we're working on right now.
Okay. So that means in the...
So it is coming soon to a theater near you,
Okay.
but probably after the last Lord of the Rings movie.
Yeah. Will it be part of the beta? The would-be beta?
It won't. Well, that's.
Good question.
We should talk. Yes. My first guess is no, but there are how
Nobody
things can
knows.
work.
Okay, thanks.
A comment on type data set annotations with the SQL types you're going to have.
I'm sorry. Can you repeat that again?
So we have annotations that we can apply to type data sets, right? How does it apply to the? You mentioned the SQL types, right? As having a switch on.
Yes.
Would that be a recommended approach versus how you would annotate your type data schemas?
So I guess I'm sorry if I don't understand your question, but are you saying is schema annotation a good practice in terms of round-tripping fidelity or types?
Yes, with the advent of
My personal notion on this, I think Stefan shares this as well, is schema annotations are evil. And what it does is it pollutes the schema, right? It's not something any other processing unit, or rather any other processing endpoint knows about. And so we try to avoid schema annotations wherever possible. And in fact, I think we can support the entirety of the CLR maybe without any annotations at all. There may be one case of where we may need to add an annotation, and we're really hesitant about doing that. So we do not believe schema annotations are a good way of doing that. If you're going to do it, match on QName, right? QName is the way that people have agreed to talk about types. Anything else? I'm sorry? We will in the XML programming model, but not in the XML format. So in any XML programming model, sure, because you own the schema, you want to modify that, great. But in terms of the XML format, or no.
There were issues with serializing XML that had a reference repeated by data structure. So I had the same reference to the same object repeated.
Yes.
Do we handle that?
Yeah, so we have two modes. The question is, do we handle referential integrity in a given graph? So we have two modes. One is, yes, we look and we'll actually track ID and ID ref for you, so you'll get it on the other side, or you can turn that off. So you get remoting behavior or web service behavior. Right. Any other questions? Great, thank you very much.